quite wrong. Untrue. They've given this genetics fellow the Nobel Prize. A man doesn't know the first thing about human nature.
But what is the answer?
Breeding, Randolph, same as in racehorses. It's in the blood.
The whole discussion started with Francis Galton. He was a cousin of Charles Darwin, with whom he did not always agree. He was convinced that it was not environmental influences that were decisive for a person, but their origins. For Galton, whether someone is intelligent and has a good character is only a question of heredity.
Is that not racist?
Yes, he was convinced that the European race was superior to others. He also believed that the English lower class was inherently inferior to the upper class. What's curious about Galton is that he tried to prove this mathematically. He wasn't initially a mathematician. He studied medicine and briefly mathematics, but dropped out when he inherited a fortune from his father. He then went to Egypt and Sudan as an explorer. He was awarded the Founders Medal by the Royal Geographic Society. He also wrote a bestseller, The Art of Travel. But what really interested him was to prove that hereditary of genius with mathematics. Galton often said,
"Whenever you can, count."
He even calculated how much gold there was in the world and whether it would all fit in his house in Kensington. It would certainly not fit into my kitchen. Galton then tried to determine how much affection people had for each other by measuring how much they bent toward each other. And the deeper they bent, the greater the affection. Galton also used the ambiguity of the term inclination for his argument. To measure inclination, he wanted to place pressure pads under the chairs of his guests. And when he was 48 years old, he published Hereditary Genius. In the book, he tried to explain his racist beliefs using scientific methods.
How is that supposed to work?
He introduced a classification system. He started with ideas from Quetelet and the normal distribution.
You already made a video about this. Everyone can find the link in the description below. But what exactly is it again?
Galton was aware that mathematics is abstract, so he invented a mechanical device that he had made. It was inspired by a game called Bagatelle and is called the Galton board. It is an upright board with a triangular array of pegs. The balls dropped on the top bounce their way down. Each time they hit a peg, they bounce either right or left. At the bottom, they are collected in bins. The balls in the bins represent the normal distribution, with most balls collected in the middle. Galton boards are still used in many schools and universities today.
This is a fantastic invention.
Galton was a polymath. He tackled a wide range of challenges. For example, he tried to create a formula for the perfect tea. Unfortunately, his original formula has been lost, so we only have his notes. We know that he spent months measuring the brewing time and the water temperature. He even developed a special thermometer for this purpose. He tried to prove that milk had to be added after the tea. I'm not sure if I will succeed here in making the perfect tea.
Fortunately, I don't have to drink it.
Galton knew that truly exceptional achievements are rare. They are at the extreme end of the normal distribution and are the exception. In his book, Hereditary Genius, he introduced a ranking system. He wasn't interested in the average person, but in an elite whose abilities were superior to all others. He called them the Eminent Man.
But what were the criteria he used for his classification?
That's the whole problem. There weren't any intelligence tests at the time, and he didn't want to evaluate professional skills. After all, he believed that all human qualities were innate. So instead, he was searching for criteria for the body. He had plenty of ideas. For the International Health Exhibition in 1884, he set up a laboratory where visitors could measure their characteristics for 3p. He tested 17 characteristics, including height, weight, punching power, breathing capacity, reaction time, and eyesight. He called it his anthropometric laboratory, and it was a great success. Almost 10,000 people had themselves tested. There's some debate about how accurate his measurements were. For example, he only estimated the height of women because he didn't dare to mess up their hairstyles.
I feared it would be troublesome to perform on most women on account of their bonnets and the bulk of their hair, and that it would lead to objections and difficulties.
He collected over 170,000 measurements, but couldn't find what he was looking for. The genius, his eminent man. He couldn't spot any patterns in the data.
Maybe he had used the wrong data.
Galton was of the same opinion. He then tried fingerprints. He believed that the elite could be identified by their fingerprints. He did achieve something in this area, but not what he had intended. He was not the first to work with fingerprints. Fingerprints had been used as signatures on documents for centuries in Asia, for example in China and Japan. The Scottish missionary Henry Ford was introduced to this technique in Japan. He was fascinated and started putting together a collection of fingerprints. When Galton heard about it, he was really interested. It was a different way to learn more about the different characteristics of people. He thought that a person's genius should be visible in their fingerprints. So he made a large collection of fingerprints himself. He also got the fingerprints of important people to add to his collection. But he was disappointed to find that there were no difference between the fingerprints of geniuses and those of ordinary people.
I have prints of eminent thinkers and of eminent statesmen that can be matched by those of congenital idiots. No indications of temperament, character, or ability can be found in finger marks, so far as I have been able to discover.
Another setback.
However, he soon found another use for his system. To be precise, in the field of criminology. Galton went to see the French criminologist Bertillon in Paris. There he learned of Bertillon's system for describing criminals based on statistics. This system was influenced by Quetelet, whom I mentioned earlier. Galton knew that everyone has unique fingerprints. The German anatomist Johann Meyer made this discovery way back in the 18th century. Of course, Galton had no idea that fingerprints develop in the mother's womb. The fact that each person develops differently in the womb means that fingerprints also develop differently for each person. That's why fingerprints can be used to identify people. Until then, the police had only been able to rely on witness statements or wanted posters with unclear descriptions, which made it really difficult for them to do their job effectively. And at a time when photographs were uncommon, fingerprints were a new great way to identify criminals. Already Ford showed Scotland Yard his fingerprinting system, but they weren't interested. Galton's authority meant the method was taken seriously and soon put to use.
But how do you go about finding a fingerprint in a large archive of fingerprints?
Galton came up with the idea of classifying fingerprints. He identified three main types: the arc, the loop, and the wall. His method was a big step forward. But it wasn't quite what he'd hoped for. He was not able to identify any physical traits that set the eminent man apart from the rest. But he didn't give up. He came up with a mathematical concept that helps us understand how properties can be related when they occur at the same time: correlation. This happens when two variables of probability occur together, even though this is unlikely.
Can you give me an example?
When it gets colder, we see an increase in the number of heaters being purchased. This can be proven statistically and makes sense when you think about it, as there is a direct correlation between the two. However, it is important to remember that correlation doesn't necessarily mean causation. It's interesting to note that when ice cream sales go up, so does violent crime. There's no direct link between the two, but both are affected by the same thing: hot weather.
That's a bit too simple.
Another example of how Galton applied his theory. He was trying to prove that sermons don't work. If sermons were to be effective for anyone, the royal family would have to be the healthiest people in England. After all, lots of English people pray for the royal family. But the thing is, their life expectancy is actually lower than that of other wealthy people. The priest said that the argument wasn't valid because people preaching for the royal family might not be taken seriously. Galton put forward another argument, because the same applies to priests who pray more than others but are still not healthier or live longer. Galton proved statistically that even lawyers grow older than priests. The problem with correlation is that it's not always possible to recognize what the common condition of the occurrence of two variables is.
But surely Galton won't make that mistake.
Absolutely. It's pretty obvious that those in the upper class back then had a better knowledge of math than those in the lower class. Galton was convinced that the reason was a difference in genetic makeup. Those from the upper class just have a better genetic heritage. It never crossed his mind that it was because the upper class kids got better education, while the lower class kids had to start working from a young age. Galton studied at Cambridge and was able to afford many private tutors. He didn't realize he was privileged and resented those who weren't.
Man is a product of a poor environment. There's absolutely nothing wrong with him. I can prove it.
Of course there's something wrong with him. He's a Negro.
Galton came up with a racial classification. At the bottom were the Africans and at the top, of course, the English people. He was English himself. This has nothing to do with science. He became a bit of a dilettante to hold on to his beliefs anyway.
It is seldom that we hear of a white traveler meeting with a black chief whom he feels to be the better man. I have often discussed this subject with competent persons and can only recall a few cases of the inferiority of the white man.
At the same time, Galton was a gentleman who felt at ease with his peers and had a lot of friends. He himself was unable to have children with his wife and dreamed of giving birth to an elite. He is the father of eugenics.
What does eugenics mean?
As he believed that intelligence and genius were inherited, only those with a better genetic makeup should have children. He wanted to send everyone else, that is the English lower class, to monasteries.
Consequently, as it is easy, notwithstanding those limitations, to obtain by careful selection a permanent breed of dogs or horses gifted with peculiar powers of running or of doing anything else, so it would be quite practicable to produce a highly gifted race of men by judicious marriages during several consecutive generations.
Many of the English upper classes took it as a compliment to be compared to a breeding stallion. Eugenics quickly became popular.
It depends on the stallion.
Galton founded the magazine Biometrica in 1901. In 1904, the Galton Laboratory of National Eugenics was born. Thanks to him, eugenics became a big movement, first in England and then in the USA and elsewhere. But Galton wasn't a politician. He aimed to prove that eugenics was based on natural laws and mathematics.
Today, he is best known as a mathematician.
He made some major contributions to probability theory. His theory of regression analysis is probably his most important work. In simple terms, it describes the relationship between a dependent variable and an independent variable. A regression is the relationship between the two values. So, for example, let's say you want to climb a mountain.
I'd love to do that.
Let's say the temperature at the bottom is 20 degrees Celsius. As you climb higher, it gets colder. There's a relationship between the height above sea level and the temperature. Mathematicians call this regression. Temperature varies with altitude and depends on it. Temperature is the dependent variable and altitude is the independent variable. Other factors can influence temperature, like humidity. These relationships can be written into an equation. He also discovered the regression towards the mean. Basically, it's the tendency for most data points to gravitate toward the mean when you've got a large number of data. After one extreme value, it's more likely that the next one will be closer to the mean. This is how extremes balance each other out. Galton observed this phenomenon after measuring the size of peas, a height of people, but it can be observed everywhere. The problem for him, however, is that the regression toward the mean contradicts his racist theory, because it says that the children of very intelligent parents are statistically less intelligent. Conversely, children of very stupid parents are more likely to be more intelligent.
That makes sense to me. Galton is right.
But it wasn't the result he was after. To be fair, I have to say that Galton was aware of this problem. He tried to show that the regression to a mean could be explained with his racist theory of rank ordering. He also produced a graph for this purpose. This graph should help you see how the average value change based on the social class. Basically, each class tends to go back to the mean average value. Of course, this assumes that the classes each have a different genetic makeup, and he couldn't prove that. Despite all his measurements and mathematical tools, it remains an unfounded claim. In the end, Galton was a brilliant mathematician, but the real reason why he did math in the first place was to prove the existence of a superior race. He was unable to achieve this. Eugenics remains an obscure political program.
We're ruined.
This is an outrage. I demand an investigation. You can't sell our seats. A duke has been sitting on this exchange since it was founded.
Nevertheless, eugenics was still very successful after Galton.
Yes, but that's for another video. I know, it's not the perfect cup of tea, but I don't care. It meets my average standard deviation. More to this next time.
I am curious. Thanks to everyone who watched. If you enjoyed this video, please subscribe. See you next time.